Okay student, this is the 13th part of matrices. 12 parts completed now. 10, 11, 12 parts are based on determinant of a square matrix and its properties and problems. Now determinant concept completed, now new concept, that is adjoint of matrix and inverse of a square matrix, like that. First one is adjoint of a square matrix. Adjoint of a square matrix. ADJA I will write. Adjoint of a square matrix. How that they define. For example, a matrix is given, say 3 by 3. Square matrix, any square matrix can take. For example, 3 by 3. So you can find its cofactor, you can find its cofactor, you can find cofactors for all the elements. Okay, after that you can find cofactor matrix. Cofactor, see cofactor, I can write, just I will write it. Cofactor matrix I can write. Intus I will write. Intus are the cofactors of those dots. After that I can find it transpose. Cofactor matrix transpose is said to be the adjoint matrix of A. Okay students, we want to find adjoint matrix A. First of all you want to find co-matrix, cofactor matrix. After finding cofactor matrix, find transpose of cofactor matrix. What you will get, that is said to be the adjoint matrix A. Okay. So here definition, if the elements of a square matrix be replaced by corresponding cofactors, then the transpose of the resulting matrix is called the adjoint matrix A. Adjoint matrix A denoted by ADJA. Okay, for example, this is a P is a matrix, nana. Yeah, A1, B1, C1, A2, B2, C2, A3, B3, C3. So capital A1 stand for cofactor of A1, capital A2 stand for cofactor of A2, and so on. So what is the cofactor matrix actually? A1, B1, C1, A2, B2, C2, A3, B3, C3 is a cofactor matrix, cofactor matrix of A. Its transpose, what is transpose? A1, A2, A3, B1, B2, B3, C1, C2, C3. This is said to be the adjoint A. Okay. To find adjoint matrix, first of all you want to find cofactor matrix. After the transpose of that gives the adjoint matrix. So one example problem. If A equal to 1, 2, 1, 1, 0, 1, 2, 1, 1. Sorry. Yeah. Find adjoint A. First of all, you want to find cofactor matrix. Each element cofactor should find. Okay. I will write. I want to take first column 1, 1, 1. Its cofactor. How can you write? Wait. Cofactor of 1, 1, 1 equal to minus 1 power 1 plus 1, and it's minor. Directly I want to write minus 1. That totally minus 1. Cofactor of another 1 comma 2, sorry, first row, second column, equal to minus 1 power 1 plus 2. Directly I wanted that column 1 minus 2. So here minus, totally 1. So next to another 1, 3, that is equal to minus 1 power 1 plus 3, 1 minus 0, that is equal to 1. Next this one, 1, 2, 1, that is equal to minus 1 power 2 plus 1 into direct that column, the row removed, 2 minus 1, that is equal to minus 1. Next 0, 2, 2, 0, 2, 2, that is minus 1 power 2 plus 2 into that row, that column removed, 1 minus 2, minus 1 here, plus 1, totally minus 1. Okay. So next one, another one is there, that is 2, 3. For my convenience, I took all ones, for calculation purpose. Yeah, minus 1 power 2 plus 3 into that row, that column removed, 1 minus 4, here minus 3, here minus, totally 3. So next 2, 3, 1, that is equal to minus 1 power 3 plus 1 into 2 minus 0. So totally we will get 2. What is this now? 3. Okay. So next 1, 3, 2, that is equal minus 1 power 3 plus 2 into that row, that column removed, 1 minus 1, 0. Last one, 1, 3, 3 equal to minus 1 power 3 plus 3. Yeah, into, what should write? 0 minus 2, 0 minus 2. Here plus totally minus 2. Now cofactor matrix of A. Just cofactor matrix I want right now. Just yeah, minus 1, 1, 1, minus 1, minus 1, 3, 2, 0, 2. This is cofactor matrix. But what I want? Adjoint matrix I want. What definition saying that its transpose adjoint A equal to transpose minus 1, 2, 1, minus 1, 0, 1, 3, 2. This is said to be the adjoint matrix of this. Okay, students, in this way you can find an adjoint matrix. Yeah, some important notes are given. These all are not important actually. Okay, if A is a order of 3 by 3 matrix and K is any number scalar, then adjoint of K of A, each element of A multiplied by K, resulting matrix adjoint is K square into adjoint of A. So generalization of this, generalization. What is generalization? Adjoint of Ka equal to K power n minus, in this example 3 by 3. In this note that is 3 by 3. Now n by n. For n by n, so what is adjoint of Kn, where A is n by n matrix, each element of A multiplied by K. So resulting matrix adjoint equal to K power n minus 1 into adjoint A. Okay. Yeah, students, actual concept is this, Nana. Inverse of a square matrix. This is very, very, very important. Inverse of a square matrix. First of all, I want to define what is the multiplicative inverse of any real number. First real number. A comma or A belongs to a set S. There exists a new number, say B belongs to S, such that A into B equal to B into A equal to multiplicative identity 1, then such B is called multiplicative inverse of A. This is the definition, or general definition I will write, multiplicative inverse definition. Okay. A belongs to S. If A belongs to S, no, not like that, wait. I will write. In real numbers, first of all, I will write. A belongs to S, there exists another element B belongs to S, such that A circle dot B equal to B circle dot A equal to E. Then such B is called inverse of A with respect to circle dot, and the property is called inverse property. Then such B is called inverse of A with respect to circle dot. Okay. If circle dot is taken as into, circle dot is taken as into multiplication, then what is the definition becomes? A belongs to S, then there exists B belongs to S, such that A into B equal to B into A equal to 1. Operation is into, automatically E becomes 1 only, you know that. Then B is called multiplicative inverse of A. So B can be written as 1 by A, provided A not equal to 0. Means that multiplicative inverse of 0 won't exist in system of real numbers. Okay, this is in real numbers. But same thing you can apply in sets also, that is not big problem. Okay, listen all of you. A is in a set. There exists another set, say B. so that A into B equal to B into A equal to I. In real numbers, instead of E you are writing 1, no? If you take multiplication as operation of multiplication. Here operation is taking multiplication, instead of E what should write? I should write in matrices. Already explained the properties. Okay. If there exists a matrix B, so that A into B equal to B into A equal to I, then this B is called the multiplicative inverse of A. Symbolically written as B equal to A power minus 1. Multiplicative inverse, don't think that this is 1 by A. This is wrong notation. A power minus 1 is not equal to 1 by A, student. So A power minus 1 read as inverse of A. Inverse of A. Okay. So what happened? Yeah, here B is called inverse of A and symbolically as A inverse. From this, what I can write now? A into A inverse equal to A inverse into A equal to I. Always this is important property, should remember. A into A inverse equal to A inverse into A equal to I. Okay. One important thing. A into B equal to B into A equal to I means, what is the order of A? That to the order of B, no, automatically. Actually, to multiply a matrix A with B, what is the condition? Number of columns of A should be equal to number of rows of B. But here what happened? A into B equal to B into A. No, that's why what is the meaning of this? What is the order of A? That is the order of B. Okay. Students, important, Nana. Very, very important inverse property. Okay, now I want to read. If for a square matrix A, there exists another matrix B such that A into B equal to B into A equal to I, then B is called the inverse of A. Okay, this is the definition. And I will write, and it denoted by A inverse, that is B equal to A inverse. Therefore, A into A inverse equal to A inverse into A equal to 1 I. Okay, students. So this is the definition. Actually, what is our target? If a matrix is given, how to find its inverse? Very, very difficult. Matrix is given, how to find inverse? How to find you want to find out a matrix, so that this into this equal to I, or this into this also I. Such a matrix should find. Not at all easy. So what is the one of the way, Nana? I will show you what is one of the way. A into B equal to B into A equal to I. Such matrix should find. No, 2, 3, 4, 2, 3 minus 1, 0, 0, 1 is one matrix. So this also I now just now I told, no, that should be all the same order. A, B, C, X, Y, Z, P, Q, R equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Now you want to multiply these two, and comparing with this you get several equations. While solving all those several equations, we get A, B, C, X, Y, Z, P, Q, R values. From that you can find inverse. This is the one of the way. I am not saying that only the way. It is one of the way. We have another way to find inverse easily. No, I will explain that now. Okay, it is one of the way to find inverse. First of all, definition is important. What is inverse? What is adjoint? Okay, so this is the definition of inverse of a square matrix. Okay, students. So some important observations are given. You should accept this. Okay, B equal to A inverse. Just now I wrote. This also I wrote. This also I explained. For the product of AB and BA to be both defined and be equal, it is necessary that A and B are both of the square matrices of the same order. Thus, non-square matrices cannot possess inverse. This is important note. One thing, every square matrix need not have inverse. Very, very important. Very, very important. Every square matrix need not have an inverse. If A possesses an inverse, then it is called invertible matrix or inversible matrix. Okay. Inverse of unit matrix is taken as I only. This is also one important note. Inverse of I equal to I only. If A is a invertible matrices, then A inverse whole inverse equal to A. So how you got? You easily can prove. That is not big problem. So A is an invertible matrix. A inverse whole inverse equal to A only. Okay. Yeah. Next important note students, IMP I can say. If A and B are invertible matrices, means inverse exist of the same order, then AB whole inverse equal to B inverse into A inverse. Should remember. AB whole inverse equal to B inverse into A inverse. Just like AB whole transpose equal to B transpose into A transpose. AB whole inverse equal to B inverse into A inverse. Okay, students listen. First of all, let some matrix C equal to B inverse into A inverse. For example, students listen, A equal to matrix B. For example, real number A equal to B, I want multiply 2 on either side. How can I put 2 into A equal to 2 into B I can write, or 2 into A equal to B into 2 also I can write. Nothing is wrong in real numbers. But in matrices it becomes wrong number. For example, A equal to B, A and B are real numbers. A into C equal to B into C, or C into B you will say, both are same. But in matrices that is not correct. If A equal to B, K into A is equal to B into K becomes wrong. We multiplied K, I multiplied K another side, but what should write? A pre-multiplication of K, you should say. Pre-multiplication of K means K left hand side. K into A should be equal to K into B only, not B into K, because product of matrices won't satisfy commutative property. Understood? For example, A equal to B given, something you want to multiply on the other side, some matrices you want to multiply on the other side, we should clearly mention pre-multiplication of matrix K on the other side, or post-multiplication of K on the other side. So, pre-multiplication means K into A equal to K into B, or A into K equal to B into K, should take care of this. Okay. Now, here matrix C equal to B inverse into A inverse. What I should do? Now I want to multiply AB, C into AB. Observe how I am writing. So B inverse into A inverse into AB. So already you know that matrices multiplication satisfies associative property. That's why this I can written as B inverse of A inverse into AB I can write. Or another words I can say B inverse of A inverse into A into B I can write. Another words I can say B inverse of A into A inverse I only, already you know that is B. So B, any matrix multiplied with unit matrix, that matrix only will get B. So according to the definition of inverse matrix, B inverse to B is I only. What I got? C into AB equal to I got. Similarly, AB into C also will get I only. What is the meaning of that? C into AB equal to AB into bracket should write. C equal to I means what is the meaning of AB is the inverse of C, or C is the inverse of A. Okay, what I can write? C equal to AB whole inverse. Okay. So what I took C means this one, no, this is taken as C. I can replace here. What you got? What you will get? B inverse into A inverse equal to AB whole inverse. So this is the proof for this note. Important. AB whole inverse equal to B inverse into A inverse. Similarly, you can extend this. A, B, C, D, so on, Z whole inverse equal to Z inverse into next number into so on, D inverse into C inverse into B inverse into A inverse. So this is the one of the important property now. Okay. Yeah, students. Another important property regarding inverse. If A is an invertible matrix, then A transpose also invertible matrix. That is important. A is invertible, then A transpose also invertible. Means inverse exists. Okay. A is invertible matrix, then A transpose invertible matrix, and also A transpose whole inverse equal to A inverse whole transpose. Okay. I can prove it. This is not big problem. Listen, students. So to prove this, I want to use the definition first of all. For the definition, A into A inverse equal to A inverse into A equal to I only. Or in other words, I can say that A into A inverse whole transpose equal to A inverse into A whole transpose equal to I transpose. Already you know that if A equal to B, then A transpose equal to B transpose only. So by using proper transpose, what I can write? A inverse whole transpose into A transpose. since AB whole transpose equal to B transpose into A transpose. So this is equal to A transpose into A inverse whole transpose equal to I only, because I transpose I only. Okay, observe students, do one thing. Let's feel that this is some B. So what you got? B into A transpose equal to A transpose into B equal to I. What is the meaning of this, Nana? A transpose is the inverse of B, or B is the inverse of A transpose. Okay, understood? So what I can say? B equal to A transpose whole inverse. So instead of this B, what I can write? I can write this. What is that? A inverse whole transpose now equal to A transpose whole inverse. I proved now. Should take care. What I wrote symbols not clearly. So B means what, Nana? A inverse. This is inverse. This is transpose. This is transpose. This is inverse. Okay. This is also one of the important property. Should remember. Yeah, students, this is our actual concept. How to find inverse of a matrix. Previously I explained one method, no? So that is not always applicable, because lengthy method. So shortcut method is there to find inverse. A theorem is given, just like A is a matrix is given, is non-singular. Non-singular means its det is not equal to 0. Its det is not equal to 0. Then only inverse exists, because some formula is given for inverse, not yet derived. Assume that this is, for example, derived. A inverse equal adjoint A by det A. Det A is a real number, no? Just like 1 by det A into adjoint A. So real number multiplied by adjoint A. So if det equal to 0, how can you get A inverse here? A inverse won't exist, no? That's why the matrix should be a non-singular, then only inverse exists. That inverse can obtained by using this formula. That should prove now. Okay, listen all of you. Now I want to prove that inverse of this matrix equal to adjoint A by det A. Students, listen. I will write neatly. Given matrix equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. Also given determinant of A not equal to 0. Okay, let capital A1 comma capital A2 comma capital A3 are the cofactors of small a1 comma small a2 comma small a3 respectively. Similarly capital B1 comma capital B2 comma capital B3 comma capital C1 comma capital C2 comma capital C are the cofactors of the remaining element. That should write. Okay. Now directly I want to write adjoint matrix here. Adjoint matrix. Therefore adjoint matrix ADJA. So transpose of cofactor matrix. Instead of A1, A2, A3, original cofactor matrix. It transpose means what happened? A1, A2, A3, B1, B2, B3, C1, C2, C3. This is adjoint matrix. Okay. Do one thing. Consider just to multiply A with adjoint matrix. What happened? Observe. A with adjoint or adjoint with A. Anything. Adjoint A I want multiply with the matrix A. Just consider. So what happened? We will observe now. Adjoint A means I want to write A1, A2, A3, B1, B2, B3, C1, C2, C3 should be multiplied with small a1, small b1, small c1, small a2, small b2, small, I think correct only, no? So a3, b3, c3. Now I want to multiply. Okay, students. Yeah. Here only I want to multiply. So I want to remove this. I think no need. Yes, no explain. Now I am multiplying, observe students here clearly, adjoint A into A equal to, yeah, you know the process to multiply matrix with another 3 by 3 and another 3 by 3 only. Yeah, capital A1, small a1 plus capital A2, small a2 plus capital A3, small a3. I think space is not sufficient. I will write again. I will write here. Adjoint A into A equal to. I will start here. I don't want to write bracket. Later I will write. So what you got first of all? A1 into A1 plus A2 into small a2 plus A3 into small a3. Yeah, first row, first column is completed. Next, here A1 into B1 plus A2 into B2, A plus A3 into B3. Yes, first row, second column completed. First row, third column, A1 into C1 plus A2 into C2 plus A3 into C3. Okay. Here, second row, first column, B1 into A1 plus B2 into A2, sorry, B2, capital B2 into A2 plus capital B3 into A3. Here, second row, second column, what is B1 into small b1 plus B2 into small b2 plus B3 into small b3. So, capital B1 into C1, capital B2 into C2, capital B3 into C3. So, yeah, second row also completed. Now, third row, first column element. So, what is that, Nana? A1 into C1 plus A2 into C2 plus A3 into C3. Next, B1 into C1, okay, plus B2 into C2 plus B3 into C3. Next. So, what I wrote wrong, I think this one. Yeah, actually we need to use this one, no? Okay, sorry. Yeah, so what is that? I will write C1 A1 plus C2 A2 plus C3 A3. Next, C1 B1 plus C2 B2 plus C3 B3. So, C1 C1 plus C2 C2 plus C3 C3. So, this is the resulting matrix. I want to erase this one. Okay. Now, I want to add bracket for this matrix symbol. This is the new matrix. Yes, so it's important. This is determinant of matrix in definition. A1 into its cofactor plus A2 into its cofactor plus A3 into its cofactor. What you will get? Det of a matrix. So, what is it? 0, no? This one 0, already explained. Any matrix, any column matrix multiplied with the product of sum of cofactors of another row or another column, then automatically summation equals 0. Already proved thing. Automatically this is 0. That I want, right? Should take care, Nana, should take care. This is important step, Nana, this is important step. So clearly I explained A, B, C, E, F, G, something 1, L, M, P given. These matrix elements are multiplied with their cofactors and added, the summation what we will get, that is called determinant. These matrix elements are multiplied with cofactors of another row or another column element. Their addition it gives 0, already established fact. That's why what I can write here directly, det A I can write here, det A 0, 0, 0 here also, B1, B1, B2, B2. So, det that one, det A only that one, equal to 0, here 0, here 0, here det only, det A. So, what happened, from each column I can take just like 1, 0, sorry, det A common, det A common. This is not matrix, Nana, don't think it is not determined. For each column det is taken, det A into det A into det A, that is not correct. This is not, I am not finding determined, just matrix application. That is why only one det A of 1, 0, 0, 0, 1, 0, 0, 0, 1. So, what I got? Det A into I. What you got, I will write here. Adjoint A into A equal to det A into I got. Det is real number, you know here. Det is real number. I can divide throughout by det. That is not big problem. And I also given det A not equal to 0, no here. Non-singular matrix. That's why I am dividing adjoint A. Adjoint A into A by this. Just I will write here. What is the problem? Just what is that? Det. Det just equal to I. What I got, I will write adjoint A by det A into A equal to I. This is result number 1. Students, what you got, again I want to write here. Adjoint A by det A into into A, we got I. This is taken as first equation. Similarly, I will write similarly. What I did first, adjoint ADJ, adjoint A into A. I got det A into A, no? If A into adjoint A, find A into adjoint A. What happened, I will write here. Similarly, A into adjoint, adjoint A also equal to det A into I only. Similarly, for the meaning of that, A into adjoint A by det A is equal to I. Second equation from 1 and 2. What I can write and observe? Adjoint A by det A into A equal to A into adjoint A by det A equal to I. So, this is in the form of A into B equal to B into A equal to I. Then what is called B? B is the inverse of A or multiplicative inverse of A. So, adjoint A by det A is the inverse of A. So, final step I want to write. Final step. Therefore, A inverse equal to adjoint matrix by det A. Okay, in this way you can find inverse of any square matrix. Inversible square matrix. Inversible square matrix means that inverse should exist, which the determinant should not be 0. Non-singular matrix means we can find the inverse for non-singular matrices only. Students, listen. To find inverse matrix, what should do? You need to find adjoint matrix. After that matrix should be each element of adjoint matrix should be divided by det A. What you will get? That is inverse of that matrix. Okay, students. Here one example is given, illustration 2. So I want to find the inverse of this matrix. How to find Nana? First of all, you want to check whether it exists or not. Means you need to find a determinant. Okay. Yeah, I will write. Let A equal to 1 0 2 2 1 0 3 2 1. You know how to find determinant. Use any row or any column. Always I will use first row. 1 into 1 minus 0 into something I don't want, right? Plus 2 into 4 minus 3. So here 1 will get minus 0. Yeah, 4 minus 1 plus 2. Okay, what I got? 3 not equal to 0. Det A equal to 3 not equal to 0. Therefore, A is non-singular. Therefore, A inverse exists. Now you want to find A inverse. So what I got? Det A equal to 3. This is also useful, no? Leave it. So now you can find. How can you find? You need to find adjoint matrix. Adjoint matrix means first of all you need to find cofactor matrix. After that it transpose gives adjoint matrix. Okay, Nana? So cofactor of first 1 1 I can say, that is equal minus 1 power 1 plus 1 directly 1 minus 0. Already this is 1, that is equal 1 only. So I want to erase this portion, and I already explained everything. Okay. Next, cofactor of 0, that is 1 2, that is equal minus 1 power 1 2 1 2 no. Okay, into that row, that column removed, 2 minus 0 that is equal minus 2. See here minus 2 only, 2 here minus 2. Cofactor of 2, that is first row, third column, that is equal minus 1 power 1 plus 3. Okay students, that row, that column, 4 minus 3, that is 1, that is totally 1. So first column completed. Now second column I am taking, second column, that is what, 2 2 1, that is equal minus 1 power 2 plus 1 into directly I want to find this cancels, 0 minus 4, here minus, here one more minus, that 4 directly. Now cofactor of 1 1, that is 2 2, that is equal minus 1 power 2 plus 2 into directly cancel, ones are minus 6, 1 minus 6, minus 5, here plus totally minus 5. Cofactor of that 0, which is 2 3, that is equal minus 1 power 2 plus 3. Okay, 0 cancelled, 2 minus 0, here 2, here minus 2, okay. Yeah, last column, sorry, last row, cofactor of 3. What is that? 3, third row, first column, that is minus 1 power 3 plus 1, directly 0 minus 2, 3 plus 1 4, that totally minus 2. Okay students, next 2 cofactor of the 2, that is 3 2, 3 by 2, minus 1 power 3 plus 2, that is what should write, 0 minus 4, already here minus, totally 4. So last element, that is 1 3 3, that is equal minus 1 power 3 plus 3, 1 minus 0, totally 1. So first of all I want to write cofactor matrix. After that I will write its transpose. 1 minus 2 1, 4 minus 5 minus 2, minus 2 4 1. Okay. Next I want to write adjoint matrix now. Therefore adjoint matrix ADJ A equal transpose of this matrix, 1 4 minus 2, minus 2 minus 5 4, 1 minus 2 1. Okay. Now you got adjoint matrix. Now I can find inverse directly. We know that A inverse equal to 1 by det A into adjoint A. A inverse equal to 1 by 3 into 1 4 minus 2 minus 2 minus 5 4 1 minus 2 1. You can leave it. This is the inverse only. Or sometimes you can multiply with 1 by 3. That is not big problem. Or A inverse equal to 1 by 3, 4 by 3, minus 2 by 3, minus 2 by 3, minus 5 by 3, 4 by 3, 1 by 3, minus 2 by 3 and 1 by 3. So this is the inverse of the given matrix. Okay students, actually this is illustration number 1. What I explained previously, that is illustration number 2. Because illustration 1 is given 2 by 2 matrix, easy matrix. Okay, let A equal to 2 minus 3 4 6. First of all, you need to find det na. Det equal to 12 plus 12, that is equal to 24, which is not equal to 0. Therefore, A is non-singular. Therefore, A inverse exists. Okay. It's a cross section. 6 to the 12. Okay. Now I want to find a cofactor of each element. 4 are there, that is not a big problem. Cofactor of 2, that is 1 1. That is equal to minus 1 power 1 plus 1. That row and that column should remove. What is there? With 6 only. Should write 6 only. That is equal to 6. Cofactor of minus 3, that is 1 2. Minus 1 power 1 plus 2. Yeah, that row, that column removed, that left with 4 only. That is equal to, here minus 4 will get. So what is next? 4. 4 2 1. That is minus 1 power 2 plus 1. Into that row, that column should remove minus 3. Already here 1 minus, totally 3 will get. Next 6 2 2. Minus 1 power 2 plus 2. Students, directly I can say that is 2. Totally 2. Cofactor matrix. 2 by 2 easy only, na? Direct method also there, I will explain that later. First of all, cofactor matrix. Cofactor matrix equal to, yeah, 6 minus 4 3 2. Adjoint matrix now. Adjoint inverse of transpose of this. 6 3 minus 4 2. Okay, students. Yeah, adjoint A you got. Now inverse I want. Inverse equal to 1 by det A. Sorry. 1 by det A into adjoint A. That is A inverse equal to 1 by 24 into 6 3 minus 4 2, completed, enough, no need to multiply, or you can multiply, that is not a big problem. But for 2 by 2 directly you can write the answer for 2 by 2. No need to do all these things. For 3 by 3 you need to find cofactor matrix, adjoint matrix, everything. For 2 by 2 no need. Note, important note. Only for 2 by 2. What I am explaining, this note is for only 2 by 2. If A equal to A, B, C, D and A is non-singular, then directly A inverse equal to 1 by det A into, just interchange these two, their places, D A, and write BC as it is with opposite signs, minus B minus C. So this is the formula to find the inverse of a 2 by 2 matrix, 2 by 2 non-singular matrix. For example, for this matrix, so A inverse directly I can write, that is 1 by det I got 24 into these two should interchange 6 2. So these two as it is, but opposite sign, this 3 and this is minus 4. So what you got, that only. So for 2 by 2 you can use this manner.